Welcome back, learners. Now jumping on to our last concept of this lesson, we are going to be looking at pressure and the relationship between pressure and the particle model of matter. How does that relate to the particle model of matter? So to start, we need to now look at the concept of the particle model of matter. What does it say to us? We know that matter is made up of small particles that are moving constantly. So every matter that we can see is made up of particles, and those particles are always in motion. Now, all particles have energy. So the particles that are in motion, for the fact that they are in motion, it means they have kinetic energy. And then particles in a solid, they have the least amount of energy, while the gas particles, they have the high amount of energy. So the reason for that is that we are saying that the particles that are making up a solid, they have the least amount of energy because those ones, they just don't move around. They are vibrating around a point. So their movement is just vibration. And so because of that, they have the least amount of energy. Whereas when looking at the gas particles and the solid particles, those ones will have a more amount of energy as compared to the solid. However, between the liquids and the gases, the gas particles will have the highest amount of energy because those ones, they are free to move around inside a container and fill up the space of a container. Whereas in a liquid, those ones, they just move around in a particular container in a particular shape as well. So, a state change may occur when the energy of particles is changed. So if we are looking at a solid, a liquid, and a gas, when we are changing the energy of the particles, so if we are adding temperature onto the solid particle, the particles that are making up that solid will start now to gain more kinetic energy, move around even more, and as a result, the solid is going to melt. And as it melts, it becomes a liquid. Now, if we keep on increasing the temperature there, we are now going to get to a point whereby now that liquid is going to come to a boil and move into a vapor or a water vapor that's now being a gas particles. So as you can see, whenever we are changing temperature from one matter to the other, there is a state change that is happening there. So a state change may occur when energy of the particles is changed. And the converse is also true that when we are removing the energy, we can also go back from gas to liquid into a solid state when we are removing the energy. Now, there are spaces between particles of matter, and particles in a gas have large amount of spaces around them. So, solid, liquid, and gases, the difference between them is in terms of their shapes and also the spaces between the particles. In a solid, there are small spaces between particles. In a liquid, slightly bigger spaces as compared to a solid. However, in a gas particle, there are more spaces between that as compared to either the liquid and the gas particles. So there are spaces between particles of matter, and the particles in a gas in a gas matter, they have a large amount of space around them. Now, particles in the gas have a small amount of intermolecular forces. So remember we said that the particles that are making up the matter are held together by the strong attractive forces. However, the strength of those attractive forces, it changes from one matter to the other. In a solid, the attractive forces are very strong. And then in a liquid, the attractive forces, they are slightly weaker than those in a solid. And then in the gas particles, as we can see here, that the forces that are holding up those particles, they are very, very, very small as compared to the liquid and the solid. So now, we are saying that particles in a gas have a small amount of intermolecular forces, while solids have the large amount of intermolecular forces. And then that means liquids, they are somewhere there in between. They are stronger than those in a gas particle, and also slightly lesser than those in a solid particle. So the gases or the intermolecular forces that are inside a liquid matter, they are somewhere in between those of a gas and also those of a solid. They are not bigger than the solid, but then slightly less than those of a solid. However, they are bigger than those of a gas or holding up the gas particles. So we are saying that if a substance is heated, it tends to expand because the particles are moving faster and further apart. So if we are increasing temperature, as we can see, we have three types of particles here, and in each one of them, the temperature is increased. It's different. So we are saying that if the substance is heated, it tends to expand because the particles are moving faster and further apart. So when we are adding energy or increasing the temperature of a particular substance, the particles making up that substance are going to be moving around more frequently and moving further away from each other. And because of that, the spaces between the particles is going to increase, and as a result, it will appear as if that particular substance has expanded. However, we know that the spaces between the particles has increased, but then the amount of the substance remains the same in terms of size. The substance doesn't expand, but the spaces between the particles, it increases and appears as if now the particles has expanded. So, if a substance is cooled, it tends to contract because the particles are moving slower and closer together. So if you now decrease the energy, or if you now decrease the temperature, we're now going to see a point where now the particles will start to move around slowly because now they don't have that amount of energy that they had initially. So because the energy has been removed, they'll move around slower and slower and slower, and by so doing, they'll move closer and closer together and appear to be smaller and smaller because they're going to be contracting. The particles are going to contract. But remember, the particles themselves, they remain the same in terms of the size. What changes is the spaces between the particles. It becomes smaller and smaller, and therefore the particle or the substance appears to be smaller and contracted. So, moving right along, if a gas is heated, the particle will move faster as they gain more energy. That means they will collide with the inside of the container more often and also with more force. Now, when that happens, it is going to cause an increase in pressure. So we are saying that if we're heating the gas particles, they're going to move around more often and collide with themselves and also the walls of the container. And because there's going to be more collisions per second, that means the pressure is going to increase. Furthermore, if a gas is cooled, the particles will move more slowly because they will have less energy. That means now the particles are going to move more slowly, and as they move more slowly, they are going to now move closer to each other, and then the particles are going to contract. So the size of the particles remain the same, but the spaces between the particles is going to decrease, which therefore means that the particle will appear as if it is now smaller, but it's just the spaces that have decreased. So the gas pressure will decrease because the particles will bounce against the side of the container less frequently and with less force. Because the force of collision, the force between the wall of the container and the particle is going to be less, and the collisions between the particles themselves are going to be less frequent, then the force is going to decrease. And by decreasing the force, we are decreasing the pressure. So as we can see from the picture that is given to us here on the side, that when we are increasing the temperature, the pressure is also increasing. And note that, now notice the movement of the gas particles inside this container. When the temperature is increased, they move around even more frequently, and the collisions between themselves and the walls of the container, they increase, and with also a large amount of force between the two. So then, when now we are squeezing a gas into a smaller volume, the particles will now have a less space to move. So now we are looking at the relationship between the volume and the pressure. When the volume or the space is small, when the volume is decreased, the pressure needs to increase. So by looking at this graph that we have here on the side, it tells us exactly that when now the pressure is increasing going to the right, the volume is going down from 6 going all the way to 1 and therefore to 0. So that means when volume decreases, the pressure must increase. So the graph on the side tells us exactly that, and also the picture here also tells us that when we are decreasing the volume, the pressure is going to be increasing. It increases from all the way from 1 to 6 all the way to that side of the positive numbers. Furthermore, when we are looking again at the relationship between the pressure and the volume, in the same way, the gas particles will collide more often with each other and with the inside of the container if they have less space to move in. So remember, if the space is small, that means there's not enough room for the gas particles to move. So that means the collisions are going to increase because the space is very tiny for them to move around freely. So the collisions is going to increase, and by increasing the number of collisions, there's going to be more collisions between the gas particles and the container, and we know when that happens, the pressure is going to increase. So small space, high pressure. And then, what we are saying is that more collisions will mean increased in pressure, because more collisions will result in a greater amount of force between the particles and the walls of the container, and we know when that happens, the pressure is going to increase. So, to reiterate, the relationship between volume and pressure is as follows again, that volume and pressure have a relationship that when the volume is increased, the pressure needs to decrease. But then when looking at the relationship between temperature and pressure, when temperature increases, the pressure will also increase. So that's what the relationship is between volume and pressure, temperature and pressure. So with that said, I hope you had as much fun as I did. Until I see you next time. Bye.